pointer. So Joy mentioned earlier the on-site consolidation cells that were done as part of the surface waste remedy. The other part of the site is there is a mine adit that discharges contaminated water at about a flow rate of 20 to 150 gallons per minute. So the second phase of the remedy addresses that underground source of acid mine drainage. So Jim Vusick talked about earlier the mechanisms that create acid mine drainage. We know we can't get the pyrite out of the system. We can't isolate all the water out of the system. So the remedy at the Captain Jack Mill is to try to reduce the amount of air contact with the mineralized zones as much as possible. That's going to be done by installing a bulkhead, flooding the mine workings to the extent that we can safely and practically, and try to reduce the generation of that acid mine drainage. So in order to make sure that we sequester that generation, we also want to neutralize the water that's in there. And we did that by providing a source of alkalinity to increase the pH. And that was done by packing a bunch of limestone in behind the bulkhead that was going to be installed. Then the bulkhead was installed along with the flow-through pipe so that we can release water out from behind the bulkhead if needed and when needed. We've designed a recirculation system so that we can encourage that neutralization throughout the mine pool and not just have it localized around the area of the limestone. Instead, some of the mine water can be pulled through the limestone bed and returned back through the system to include this recirculation to allow for additional neutralization. There's a pretty extensive monitoring network that I'll talk about briefly. And then this record of decision was actually written with a contingency that after we install this remedy and we monitor the performance for a couple of years, if we can't meet our water quality objectives, we look at an exit treatment system as well. Okay, so again, remedial features. Here's the kind of the limestone that was packed in upstream of the bulkhead. Placed about 500 cubic yards of limestone in there. That was as much as we could get in. There was an existing stope that had collapsed and blocked up the tunnel behind that. We didn't want to remove it. And so that was what we could physically fit in the volume of tunnel that we had. The bulkhead itself is a 15-foot thick concrete plug with some pipelines that go through it. So this is a 12-inch pipe here, and it's valved. And then there's also a 3-inch pipe up here that goes through that bulkhead as well. And we're in the mine workings about 650 feet at this point. Okay, and this kind of shows the overview from the surface. So here's the mine waste dump prior to the reclamation work that was done on the surface. So here's the adit discharge. The mine tunnel falls back here. The recirculation, so this is the location of the bulkhead. Then the recirculation pipeline, we're pulling that water again through that limestone bed, setting it back up through a pipeline, and reintroducing it into the system upstream to allow for that continual recirculation. And then of course there's other monitoring features. So in an ideal world, if everything goes according to plan, the water will reach some static elevation that was pre-existing. The mine pool will be essentially neutral. We won't have any more acid mine drainage generation occurring, and we can just shut down the system and won't have any maintenance required. But in the real world, we know that there's a lot of things that can go not according to plan. We may have to control the water level. It may get too high and we have to allow for controlled releases out of it. We may have problems with the recirculation system. You know, there's scale that can build up or precipitates that can clog things up. We may have ongoing sources of metals and generation of acid mine drainage. And we might have to add in more neutralizing agents. And again, we might need that second phase of treatment with the ex situ biochemical reactor. So we need to be adaptive to the system. So the idea is, we've got the bulkhead installed, we're going to close the valve, and we're going to start monitoring the water level. So we did a very brief test on it just to make sure that the pressure transducers and everything that were installed function properly. And so you can see this is kind of a continuous reading of the elevation of water behind the bulkhead.
So Mary, what's that water level going to be in the end?
So Joey just asked a very good question, and that is, what will be the water level of the mine pool? Well, that's a great question. And again, we don't fully know the answer to that. What we do know is it's not going to go over 211 feet, because that is our first opening. If you look at the elevations of the attic here, this is the well that we put in order to be able to hold that water through the limestone system, and that's 211 feet higher.
So what are you going to do if the water goes that high?
So if the water goes that high, that's a great question. What are we going to do? Well, we can release water. Again, we've got these flow through pipes, right, installed in the bulkhead. And so we've got this 12-inch pipe. This kind of shows the profile view. And it's got these perforations on it so that we can take water through there and release it in a controlled fashion if we need to.
And what if that pipe clogs, Mary?
Yeah, that's true. The pipe might clog. That's a good question. So, if that pipe clogs, well, we've got contingency for that. We've got another pipe that goes through the bulkhead. We've got that other 3-inch line that's up higher that ties into the same piping system, and that can also control the level of water at the next. We can discharge it out through the portal. Okay,
that's great, but what if that pipe clogs?
Okay, so that pipe might also clog.
I can have her
Now we're getting crazy. Well, if that pipe clogs, we still are okay, because we've got 3 borings that directly go into the mine workings. And in an absolute emergency situation, we can go ahead and we can pump water out of that and still control it in a managed system.
So what do you do if the water comes out as contaminated seeps?
So, okay, maybe the pipe doesn't clog and the water doesn't get too high, but it forms these seeps that are contaminated. Well, we need to make sure that that doesn't happen. And we've done that by doing an inventory of the existing seeps that are there. We've got some background data. We know what the existing water quality is. And as the level in the mine pool continues to increase, we're going to go and do additional seep surveys. So we've got planned a zone for every 50 feet that the water level comes up, a new seep survey will be performed. So that you can see the aerial extent at 50 feet, 100 feet, 150, and 200 feet. And of course we know it's not going to get above that.
What do you do with nearby groundwater? Will that be impacted?
Okay. You know, there's a lot of frustrations with being a project manager. So one of them is you gotta realize what you don't know. So maybe there's not seeps going out, but there's additional impacts to localized groundwater. So this system includes an extensive monitoring network. And what we've done is install a series of ERT arrays, electrical resistivity tomography arrays. You can see that, go back, there's a series of these lines. This one goes along the spine of the tunnel. There's 2 lines that run perpendicular to it, and then there's several lines that run down the borehole so that we can monitor the mine pool as it's filling. All of these ERT systems report back to a central data communication system, and we've got internet capabilities or satellite capabilities so that we can collect that data and process it. Okay, so, okay, all right. So what does the ERT data show us? Well, it's going to show us changes in conductivity or resistivity. So this is some background data. So this blue line, that's an area of high conductivity, so that's the water in the tunnel that's there now. And then you can see these are just, each red dot is where one of those arrays are, so these are the down borehole ones. So again, we're going to, as the mine pool fills, process this data and look for changes in conductivity or resistivity. This is pretty fancy stuff, and we've got a lot of faith in it, but just to make sure, we've also got monitoring wells that have a lot of water quality meters in them. So these are standalone systems. They collect water quality parameters. Again, it's connected through a satellite system, and so that data is available remotely. and of course, old-fashioned sampling. And we're also going to continue a very rigorous and robust sampling program just to verify the data that we're getting right. We can, when the recirculation system is running, again, we can remote into it. We can check to see what the water level is behind there, what the flow is, and make sure that it's running through that limestone neutralization system. So again, other contingencies. So maybe the recirculation system runs, but the pipe clogs. Well, we installed 2 redundant pipeline systems. So one's connected up. If that one clogs, all we have to do is uncouple that one from a couple of flanges, fit the other one in, and we're good to go. And that gives us an opportunity to replace the one that's clogged if needed. What if the pipe leaks? Again, we're going, a few hundred feet on ground surface. We don't want it to create a problem. And so both of the pipes are in a secondary containment. So if there were to be a leak, it would continue down that secondary containment and back into the mine pool system. So what if the limestone that we put in there isn't enough to neutralize the entire mine pool? Well, we can add additional alkalinity, either in the form of a caustic soda, sodium hydroxide, or a lime slurry. This is the reintroduction location. So you can see this goes down into the mine pool. And we left a 2-inch line here with a blind flange on it. So if we need to connect up any other type of a chemical tote or something, we can add additional amendments into the system. Okay, if neutralizing it still doesn't do the job, we've got other plans that we can incorporate. We can add in additional reagents. Some of the stuff that maybe Jim was talking about. We can add in a carbon-based product to help promote that sulfide precipitation that we're hoping will occur in here. And if it still doesn't improve enough, we still have the contingency of the ex situ biochemical reactor, which Katie talked about in quite a bit of detail. So, in conclusion, we are trying a relatively novel approach here. Again, trying to get out of the perpetual active treatment system. There's a lot of unknowns. We realize that there's a lot of unknowns with this, so we have to design a lot of flexibility in the system. We have to be able to adapt to the changes that we see through the monitoring program. We don't know, if everything's going to work out perfectly. Well, everybody kind of hates to be the guinea pig, but we are in the situation. There might be things that we learn that you're not supposed to do. And we can do a presentation on that next time, right? But so we're trying to figure out how this works and what we can adopt it for other sites.